Hello everyone, welcome to Data Engineering Studies. Today we are going to build something really exciting, an AI powered web application using Python's Flask library and Azure OpenAI's function calling feature. In this tutorial, you'll learn how to create an intelligent web assistant that doesn't just give weather data but provide personalized recommendations based on current condition. By the end of this video, you will understand how Azure OpenAI function calling works, building a Flask application from scratch, connecting AI models to real-world API, and creating a web interface that user can actively interact with. Before jumping into the code, let's first understand why function calling really matters. It gets the real data instead of AI making up things. Here is the problem with traditional AI. If you ask AI what is the current weather in Paris right now, AI doesn't actually know. It might guess and make up an answer based on pattern it learned during training. It is called hallucination. With the function calling, AI calls the actual weather API, gets the real temperature, humidity and conditions happening right now, and then give you accurate information. Next, because of function calling, AI avoids wrong answers because it uses real function results. Next, the function calling is safe because AI can only use the function you allow. This is about security and control. AI doesn't have unlimited access to your system. You explicitly define what function it can call. The next key feature is it works easily with backend like Flask or any other API. Now let's talk about what exactly happens when user interact with weather application. I'm going to break down each steps so you can see how function calling works in practice. As a first step, user asks a simple question, what is the weather in London? User type this in our Flask interface and hit submit. Our Flask application sends this question to Azure OpenAI. AI model analyzes the user intent. It understands that user is asking about weather, and more importantly, it needs current data to answer accurately. Azure OpenAI decides it needs to call getWeather function. AI doesn't have the weather data, but it knows this function can retrieve it. So in step 4, AI returns a special response to our Flask application. It calls the getWeather function and passes the argument city equals to London. Here, AI intelligently parses London from user's natural language query. In step 5, our Flask application receives this function called request and executes the actual getWeather function with London as parameter. This function makes HTTP request to OpenWeather App API. In step 6, the Weather API responds with real data. For example, weather is 15 degrees Celsius and the description is cloudy. This is the actual current weather information from London right now. In step 7, we send this weather data back to Azure OpenAI as function result. AI now has real information it needs and generates a natural helpful response. It is 15 and cloudy in London. Consider bringing an umbrella. Notice how it doesn't just repeat the data, it provides personalized advice based on the condition. This entire flow happens in seconds, giving users an intelligent conversational experience backed with real data. This is the power of combining AI response with function calling. Before getting into the code, let's see how we organize our project. Here is our project structure. We have a main folder called web app that contains everything. Inside the folder, we have app.py. This is our main Flask application file where all the backend logics live. That includes Azure OpenAI integration, weather API calls, and function calling implementation. Next, we have templates folder which hold index.html file. This is the front-end interface where user will interact with our weather assistant. Finally, we have .env file. This file is crucial because it stores all the sensitive information like API keys, Azure endpoints, and credentials. This is a simple structure that keeps everything organized. Before further ado, let's get into the practicals. First, let's get our weather API setup. We are going to use OpenWeatherMap for this demo. This is free and it is perfect for our project. In order to get the API keys, I'm going to click API and scroll down. Let's click current weather API data and scroll down and click more details. Click on the free and click get API key. Now click sign up. I have already signed up using my credentials. If you don't have an account, you can create a free account and log in using your credentials. And now click the tab API keys and you can generate your keys here. I have already generated. Here is my key. It is important to keep this key safe. After this demo, I'll delete my API key so that my API key will no longer be valid. Let me copy my key and let me go to Visual Studio Code. Here is my project directory and inside the project directory we have templates folder and inside the templates folder we have index.html. Here is our app.py and here is our .env file. I have created an environment variable as OpenWeather API key and here I am going to paste my key. As a next step, I am going to Azure portal and I am going to deploy my model. Let me go to Azure portal. Here is my Azure portal. I have already created a OpenAI resource. If you would like to know how to create a OpenAI resource, I have explained this in my previous video. I'll give the link for the video in my description. Let me go to my Azure OpenAI resource. Next, I'm going to Azure OpenAI Foundry portal. Inside the portal, I'm going to deployments and I'm going to deploy a model. For this demo, I'm going to choose GPT-5 chat. You can choose other models too. Let me select GPT-5 chat and click confirm. Here I'm going to have all default settings. Let me click create resource and deploy. My model is deployed successfully. I see the provision status as succeeded. Here is my model name. Here is what I need to grab from Azure. I need the endpoint URL. Let me copy this and go to Visual Studio Code. I have created an environment variable Azure OpenAI endpoint. I'm going to paste my endpoint here. I also need the API key. Let me go to Azure again. Here is my key. Let me copy my key and I'm going to Visual Studio Code and paste my key. For storing the key, I have created an environment variable Azure OpenAI API key. Now we have our environment file to store all the sensitive information. I have created the environment file in the root. It is important that never share this endpoint and API key to anybody. After this demo, I will delete my resources so that my keys will be no longer be valid. Now that our credentials are set up, let me go to app.py. As a first step, I'm going to import all the libraries that are needed. As a first step, we are importing Flask. Flask is our web framework. From Flask, we need Flask Flask is needed to create our app. Next, we need render template. This is to display our HTML page. Next, we need request. This is to handle user inputs. Next, we need JSONify. We need JSONify to send JSON response back to the front end. Next, we have from OpenAI, import Azure OpenAI. This lets us to communicate Azure GPT model using Azure function calling. Next, we are importing requests. This is to make HTTP requests to OpenWeatherMap API. Next, we are importing JSON. This helps us to parse and handle JSON data. Next, we are importing OS. This helps access to operating system functionalities. Next, we have from .env, import load.env. This is to load our environment variable from .env file. We have our .env file that we just created. Now let's initialize our Flask application and configure our OpenAI client. First, we have called load.env function. This is to load all the environment variables we defined earlier. Next, we are creating Flask application instance. Next, we are setting up Azure OpenAI client. We are retrieving the Azure OpenAI endpoint and Azure OpenAI key. We are retrieving these details from the .env file and we are storing these details in a variable. Next, we are specifying the API version. This specifies which version of Azure OpenAI API we are using. This version supports function calling, which is exactly what we need. Now let's define the function that calls the weather API. We have defined the function getWeather and we are passing city as the argument. We are making HTTP GET request to the OpenWeatherMap API. Look at the URL structure here. For openweathermap.org, we are passing the city name and our API key. We are getting this API key from the .env file and we are specifying the units as metrics for getting the weather in Celsius. I hope it makes sense so far. At the end, we have specified .json. This converts the API response into a Python dictionary. Now we are structuring the weather data into clean format. From the weather data, we are getting the city, we are getting the temperature, we are getting the weather description. If there are many description, we are getting the first description. The description meaning cloudy, clear sky, etc. Next, we are getting the humidity percentage. This function returns exactly what we need, clear formatted weather data. Next, we need to tell Azure OpenAI about our function. We are creating a list of function definition. We are telling Azure OpenAI about our function. First, we are providing the function name that we created earlier here. This is the same function name. Then we are giving a description that get current weather for city. This helps AI to understand when to use this function. Then we are providing parameters. The parameters are structured as object and we have mentioned city as our required parameter. So our AI must provide this parameter to this function. Now let's create our Flask routes to handle user request. First, we have a decorator defines our home page route. Next, we have defined a function home. This function handles request to the home page. This renders our HTML template. When the user visits our app, they will see an interface we will create in index.html. We will create index.html shortly. Next, we are defining our chat endpoint. It only accepts post request because we are sending data. Next, we have defined chat function. This function processes user message. We are extracting the user question from JSON response body. Now comes the critical part. We are calling OpenAI. We initiate a chat completion request and we are using the model GPT-5 chat. This is the model we deployed in Azure. We are sending this user message to the AI and we are also passing our function schema that we defined earlier. Here, this tells AI it can call getWeather function. Next, we are defining function called as auto. This tells OpenAI to automatically decide whether it needs to call the function based on the user question. If they ask about whether it will trigger the function call. Now we are checking if AI wants to call the function. We are extracting the arguments the AI wants to parse from the user question and we are calling the getWeather function with the city name that AI extracted. Now we are sending the weather data back to AI. We are making a second API call. We are using the same GPT-5 chat model, but this time we include three messages. The user, the content, that is the original user question, and our function name, which is getWeather. This function returns the actual weather data. AI now has the real data generated from the natural response. We are sending the final answer back to the user. If no function calling is needed, we are just returning the AI response. Now we are starting our Flask server and we are using the port 5000. I hope the app.py makes sense. Let's quickly recap. We have imported the Flask and the OpenAI libraries. We are storing the credentials in the environment variables. We are creating a getWeather function to call the OpenWeatherMap API. This is to retrieve the real weather data. Then we are defining a function schema that tells Azure OpenAI when and how to use weather function. Next, we created two Flask routes. One serves our HTML interface and the other one to handle the function calling. User questions go to Azure OpenAI and the API decides if it needs weather data. We execute the function and return the intelligent natural language response. Now let's create our front-end application. In order to do that, I'm going to index.html and create our HTML page. These are our standard HTML declaration. Our root is HTML tag. We are adding some basic styles. Next, we are adding a title. Our title is Weather Chat Assistant. Next, we are creating a chat container. This is where our chat messages appear. Next, we are getting an input from the user. This is where the user types the question. And we have a placeholder question. Now we are adding interactivity. We have a send button. We attach a click handler to our button. We are extracting and cleaning the user message. We don't proceed anything if the user message is empty. Next, we are displaying the user message in the chat and we are cleaning the input field. Next, we are making a post request to the Flask backend. We are passing the header and the body. In the body, we are passing the user message. Next, we are parsing the JSON response from the Flask. And we are displaying the AI's response in the chat. Next, we put focus back on the input for the next question. Next, we attach a key press event listener to the input field. We are checking if the pressed key is enter. It programmatically trigger the send button. That is pressing the send button or the enter both does the same functionality. Next, we have get element by ID message input. This automatically puts the cursor in the input field when the page loads so that the user can start typing immediately without clicking. At the end, we are closing the Java block and we are closing the body and the HTML. This is our Flask front-end application. Let's save our code and run our application. Let me trigger my application. I am in my project directory. Now I am going to run my Python file app.py. We see that the Flask application is started and it is running in localhost 5000. Our server is running. Now let's click this link and go to the application. Our application is live. Here is our weather chat assistant interface. Let me ask some questions. What is the weather in Chennai? We got the response that the current weather in Chennai is misty with the temperature around 25 degrees centigrade and is 77% humidity. Let's ask some other specific questions. Should I bring umbrella to London today? We got a response that it is about 13 degrees centigrade in London today with broken clouds and quite high humidity. There is a good chance you will get a bit of drizzle or light rain. So bringing an umbrella would be a smart idea just in case. We got interactive response. Let's ask another type of question. Is it raining right now in Tokyo? We got the response that no, it's not raining in Tokyo right now. The weather shows few clouds with temperature around 14 degrees centigrade and humidity is 59%. We have successfully built and completed AI-powered weather application using Flask and Azure OpenAI function calling. The key takeaways from this video are: function calling is a bridge between API and the real-world data. The two-step process is elegant. AI decides when to execute the function and AI generates the natural response. You can extend this application in your project. If you find this helpful, please click the like button and subscribe to our channel Data Engineering Studies for more AI tutorials. And don't forget to share this video to anyone who is learning AI. Until then, I'll see you in the next video. Thank you.